So we've got three graphs here. We've got a velocity time graph, and then these bottom ones are distance time graph. And we've got two straight lines here, which means that whatever is on the y-axis is increasing with the same by the same amount with every unit of whatever's on the x-axis. Now, in all of these, it's time. So in other words, we can say that the rate of change of this or this is always the same if it's a straight line. So the rate of change of velocity is the same in both these cases. Apart from they look a little bit wobbly, but they're supposed to be straight. So the rate of change of velocity is the same. What is the rate of change of velocity? What does it mean? That's acceleration, isn't it? So in other words, acceleration is the same. So both of these describe a constant acceleration. The purple one is a higher acceleration because a larger increase in velocity occurs in the same amount of time. If we go down to this one, now it's the rate of change of distance over time. The rate of change of distance is speed by definition. And we can see that after this amount of time, the green's only traveled that far, the black one has traveled a little bit further, and the purple one has traveled the furthest. So clearly the purple one is the fastest. And that would be that same thing would wherever I drew the line, because the purple one is always the fastest in every case. So this tells us that the steeper the line for a distance time graph, the faster it is. In other words, if you go down to here, the blue line is getting steeper and the green line is getting less steep. But they're both, the blue and the green line, are going up. In other words, this word here is basically the same as distance. The distance is increasing in both cases, the blue and the green, because they're both still moving forwards. It's just that the blue one is moving forward at a faster rate after every second, and the green is moving forward at a slower rate every second. And the pink one, somehow the distance is going down. You can't really do that. You can't go down. You can say that if I went backwards and I was measuring how close to, or how far away from wherever I am, I can measure that with every distance, with every second, and then that could go down. But really, we're talking about displacement then, because we're including a direction. And so this would be a displacement time graph. So the only way you can make displacement go down is by going backwards. So the description of the pink line would be constant velocity, because it's still a straight line, but backwards. Okay,